Good morning, everyone. How's everyone doing this morning? Hopefully you are all good. Here's the coffee stir. Oh yeah. Hopefully everyone's good. Gonna move this to the side. We're gonna clear some room. We're gonna do a little bit of mailbag unboxing. And then we're going to move on to testing the MCP down there. Good morning, Franco, and good morning, Kurt, if you folks are here. Am I on time? The stream was for 8 o'clock, right? Like for right now? Oh yeah, and I went to, I photographed some deer not that far from where I live. Good morning, PC Board Repair. So I took the main camera out and I went and took some picture of some deer. It's just a short drive from the house. Oh my God. PC Board Repair, it's a shame we met so late because I could have had you on the podcast. Don't know if you know this, my main channel, I have like 140 podcast episodes with creators, scientists, makers, some very famous people on there too. MCP, I never remember. MCP 23017. Had Electro Boom on the podcast. Dave Jones, EV Blog. Big Clive. Had lots of people on. How's it going, Kurt? Good morning. Kurt, have you been chatting a lot? I don't recognize your name. Or have you just been a lurker, or are you new here? Let me know. Oh yeah, I gotta take the viewfinder off. Put the viewfinder cover back on. There we go. Don't really use this camera as an optical camera very much anymore. Yeah. Mostly use it digitally. Did I take the lens cap off? No. Okay, so this is the watch stuff from yesterday. We will not be building a watch today. The most important part, first time writing, usually just watch or listen. Well, welcome. The movement hasn't come in the mail yet, so that's a shame. But we're just, it is what it is. We are not building a watch today. Oh, but I did fix the nozzle. Look, I 3D printed a nozzle for the little duster. So this was the one that came with it. You see, it's not enough plastic in the mold. 3D printed my own. It was a quick keycad. what am I saying? FreeCAD project. Oh, this is new, I think. Yeah, this is new. I'll have to unbox this. Put the band in here. All right, so I want to show you guys something. So, new stuff came in the mail, obviously. The mini round display. No, it's not. So, all right, let me watch your eyeballs, folks. So, remember when I was talking about my fake Seiko logos and stuff were coming in the mail? Watch how they ship this stuff. So this is a no-no. If your customs agency figures this out, you are not getting your package. So in here, there's a silver polishing cloth. Okay, so you open it up. It's just like it's a microfiber. This is not what I ordered. I didn't order microfiber. I ordered my Seiko logos. So here is a card. It says, "Dear friend, if you can't find the product, please keep the box and read the message in our AliExpress store. Contact us on WhatsApp, whatever. R logo means Rolex. S logo means Seiko. Bulk orders have discounts." And then French, Spanish, and German. But they send you a video and they show you, look, you dismantle the box. Here are my stickers. Crazy, huh? Absolutely crazy that they would hide it in the leaf of the box. So anyways, this is my sticker. So I chose the Seiko with the S and the automatic, and you've got the little dot. It'll line up the center. Wild. So yeah, if your customs agency inspects and finds that, that is a concealment, they will for sure take your stuff away and then probably ban the seller. All right, a couple more watch things. So this I opened because I thought it was the movement, but it is not. So this is a movement stand. So we're going to use this on the stream where we build it. So they're NH35. So that's the movement will sit in here while we work on it. A little machine lip there. I could have 3D printed this, to be fair. And then there's also a couple movements that fits as well. And then this is the dust-proof enclosure. So basically it is a soft, like a springy bottom, and when you why does this have a peg in the middle? Anyways, I thought this was just a box to hold your movement so it doesn't get dust on it while you're working on it. Like while you're not working on it, I should say. Very cool stuff, this whole watch thing. Next up, I bought this in haste. So I thought this was a set of Acnes, A-K-N-E-S, sticks, TMRs. But they aren't TMRs, they say they're TMR. But it's not from Acnes, so I'm kind of surprised. I wanted the top of the line stuff, but you can see the magnetic system in there. It's by Gitful. Good morning, Lockwatcher. Ginful. Sinful. Ginful. Anyways, there's the you can see the magnet is on the very bottom there. I was really hoping, I don't know why I bought these. Gonna be very honest. I had a bunch in my cart. Yeah, they're joysticks. Had a bunch in my cart, and I wanted the Acnes, because what I did. So these are the Acnes. Basically, these are the best of the best TMR sticks on the market. Well, that fell. Oh, here it is. So they're the best of the best sticks on the market. And I have a Xbox controller that I wanted to replace the sticks on. So I bought the Xbox version, but I didn't buy the Acnes in my haste. I wasn't, I guess I wasn't paying attention. And so I ordered these TMRs that are not for PS5, or not for... I made a mistake, basically. So that kind of sucks, but it is what it is. And we're going to use them anyways. We're just going to have to integrate them into another project. Because I'm not taking apart my Xbox controller. This guy. There's dust on it. So I'm not taking apart my Xbox controller to install some maybe inferior sticks. Don't know. Please don't fall. Okay. So there you go. Finally, my alcohol bottles are here. This is what this is. Pretty sure. Yep. We're going to be filling one up this morning. So these are a bunch of these squeezy bottles. Main difference that the better ones were treated with Dan's coffee strengthening treatment. No, they haven't yet. They haven't been shop baptized yet. So these squeezy bottles, and they take these lure lock needles. And this is great. I'm going to put alcohol in this one like now. I do have my alcohol bottle here. Good. There's a little silicone cover. Perfect. So this was like $5.50 Canadian. You got all the lure lock accessories. You got the bottle. Those can be anything bottles. Yep. Yep. Perfect. We're going to put the alcohol in here. It's a little hard to dispense. This is why we've got the bottles now. During COVID times, my dollar store, there's a dollar store just a short drive from where I live. My dollar store didn't carry 99.9% or 99% alcohol. Now they do. So $3.50 for a bottle of 99%. Very good. I got some on my fingers, so now my skin is dry. 3D printed funnel, yeah. But for the amount of time I'm going to be doing this, which is like nearly never. So this is good. So this I can apply alcohol exactly to where I need it. That's good. And we've got a shit ton of other bottles. So I can have an alcohol bottle at the 3D printer. I can have one here. I can put flux in them, like some people in the stream have suggested. I would need to get some liquid flux. But this is perfect. Don't know why I waited so long to get these. Just needed the motivation from having a workplace that uses them. Crazy though, the workplace where I just quit, I'll just call it the repair shop. Sell this recordings to AI companies. You don't need to sell the recordings to AI companies. They're just going to take it. It's going to be available for free on YouTube. So the repair shop where I used to work, they had anti-static bottles for this, so a little bit more premium. Okay, and this is unrelated to electronics. These are fishing hooks. Oh, they taped it down. Yeah, I quit. So I was hired at a repair shop to be a solderer, but the vast majority of what I was doing was IT work and not soldering. So I was like not super happy, but then an opportunity came up which I accepted, and I start on next Tuesday. So on Tuesday I start work for a tech company. I'm making 40% more than I was at the repair shop, and I'll be basically a PCB. The role calls for a PCB design engineer, but I'm not an engineer, so PCB design technician, I guess. So yeah, I worked only 2 months at the repair shop, the soldering job, until this opportunity came into my lap, and I was like, I have to apply for this. Like, this is like right up my alley. And then here we are. Yeah, I have a new job. Yeah. I haven't started yet. I am very nervous. Very nervous because it's a short-term contract. It's a 4-month contract. But their intention is to move the short-term contractor to full-time if they work out. And so if I work out, and by that I mean like if I work properly, it's going to be another like 60% raise from there. So yeah, very nervous. I don't have very much time to impress them. I asked them for what I will be working on, what kind of projects. And they gave me, they're like, oh, it's this brand chip and this part number. So basically, they would say like Atmel ATmega 328P, for example. That would be like if I was working on Arduino stuff. So I went to the manufacturer's website, typed in the number. The price for this device is RFQ. And the data sheet is you have to be part of an improved company to access the data sheets. So I was like, oh, great. I won't be able to do my pre-research. You've worked for Motorola, Canon, Wells Fargo, Siemens, Safran, and OLG, as well as your own electronics repair shop. That is so cool. Yeah, I worked for an electronics repair shop for 2 months. I don't want to disparage them, though. So we're working on the MCP. Don't know if we'll be able to see the code here. MCP 23007. 23017. You're 65 now. Do you still repair things like for customers, or are you just doing YouTube stuff? Trying to get you a good view of the legs. It won't focus very well. MCP 23017 expensive. Expensive by my standards. I think they're only $1 or so a piece. Let's go check actually what the current going rate is. MCP 23017. That's interesting. You get them in expansion boards. Let me see. Sometimes it's cheaper to rip the chips off of one of these. So like $3 a pop. MCP. What? Why is that so expensive? Maybe they became expensive? I don't know why it's so expensive. How much did I pay for them? Build stuff for yourself. You repaired many things in the last month. Stove, water heater, LCD TV, many cool things. Nice. During my time at DeVry, I ran a company designing and making PCBs. Ended up making PCBs for both students in the university. Paid for your school. That's very cool. I am hoping not to have to do hustle culture stuff. So here we go. They're $2 a pop. That makes more sense. Let's check Mouser. 23017. So, okay, locally, they are $2.33 Canadian each. That's not bad. Jesus Christ, look at this bad boy. It's in a like a BGA package. EML. What's the... How come I can't scroll sideways? Whatever. So they're not very expensive. They're just expensive on AliExpress. 40,000 in stock. I2C is a fairly slow standard, though. There is an SPI version as well. Oh, big stretch. They are a very cool chip. I think if I need more, I might just order them like locally. All right, back to work. Oh yeah, wait, I wanted to get Gwen to fix the chat.Quinn. I have changed my mind. I would like it to only do outputs, switching between high and low, one IO at a time, until I pull pin 0 of the RP 2040 0 low. Please input pull up, please. And then when pin 0 is pulled low, I want the inputs to all, I want all of the MCP 23017 IO to be inputs with pull-ups if they have them internally, and then display the state of all the inputs on the serial monitor. Thanks. Gwen will do this for us while we work on our setup. And it says GP4 is SDA and GP5 is SCL. I have to write this shit down because I am old. You know what? Literally have a whiteboard for this. Okay, so sounds like an IBM keyboard. It's a Chinesium mechanical keyboard, but I bought it because it's hot swappable. So I can repair the keys, and hopefully it's the last keyboard I'll ever have to buy. So RP 2040, and then we've got GP4 SDA, GP5 SCL, good. And then we need the MCP. The MCP pins, we'll have to figure out what we need for that. So I highly recommend the keyboard I have. Okay. So, yes, the keyboard I have, I highly recommend it. It is Chinesium. It's by Red Dragon. Is it this one? Yes. Yes. So what I like about it, has a volume wheel. I use that stuff all the friggin' time. And the keys are hot swappable. So you can just swap your keys in and out for different ones. You can change the keycaps. Thank you, PC Board Repair. And what is exceptionally good about this keyboard is you put it on, you go here, camel, camel, camel. So camelcamelcamel.com. You paste the link, I'll just go to the Canadian one. You paste the link into here. Okay, it tells you the price history. As you can see, it often goes on sale for like, I don't know, not that much. But if you look here, there's historical, oops, that's not what I wanted. There's like historical lows at $62.99. So you set up a price alert somewhere there. You set up a price alert and you get an email when the price drops. And that's how I bought it. So I bought it at like the low here. So I think $63 Canadian. And it makes it 45. I don't know what that means. So here, I'll give you an affiliate link for my keyboard. Here we go. I'm just going to check how much I actually paid for it. Oh, I actually paid $71.99. Still decent price. Ooh, a good 1% commission. Fantastic. So yeah, hopefully last keyboard I'll ever have to buy. Let's do a .com. $580. Oh, it's on sale on the US site. So 2.5% commission, way better commission. Copy affiliate link. And here's the US and worldwide one. So in the chat, I am a big fan of things that will last a very long time, repairable things. I have bought a framework laptop because of the durability and the repairability. 23017 data sheet. So yeah, highly recommend. All right, so the MCP, so 1 through 8. 1 through 8 is GPB. And then 21 through 28 is GPA. Okay, then we've got a not reset. So pin 18. And then 15, 16, 17. It's A 012. And then Pin 14 is NC. Pin 13 is SDA. Pin 12 is SCK. Pin 11 is NC. Then VSS is pin 10. And VDD is pin 9. You need a new keyboard? Put the price alert. It goes on sale kind of often. I personally don't like the blue switches it came with. So one day I'm going to swap them all to Utemu blacks. And when all the keys are out, it's a good time to clean it and vacuum it. So at some point watching a podcast, I'm going to do all of that work. Okay, then we got GP0 here. GP0 is for my select. Okay, so that not reset, that means if I pull it low, it shouldn't reset. VDD and VSS. VSS is weird. So VDD is your in 0.3 to 5.5. But really supply voltage, yeah, 1.8 to 5.5. And then VDD rise supply current. Yeah, I think we're good. All right. So, tie it to CPU reset. I'm not going to tie it to anything for this test. All right, so all we should need is SDA and SCL. So I'm going to need some male-to-male jumpers here. I wish you would step back from that ledge, my friend. Always do that. So we need a GP4. That is this one. To pin 13. Well, that's a stretch. Way out to pin 13. And then we need GP5, the clock, to 12. Good. There we go. And then we need, I guess all of these are going away. We're going to power this from 3.3. So the 3V3 pin is the third pin here. That goes to VDD, which is 9. And then we're going to ground to ground. Which is 10. Right? Am I right? Yeah, VDD. It's going to be a little hard to probe the legs, but not too bad. And then I think we need the address pins tied. Address selection A01 and 2 tied to ground. If you tie them to 3.3, you need to change the initialization. All right, so we need to tie 3 IOs to ground. So that is these 15, 16, and 17 to ground. So 15, 16, and 17. We're just going to tie them hard to ground. Don't need any resistors. We're just testing. Like this. Likely if I make a PCB, I would just have like 500 ohm resistors to ground just to make sure there's no like excess current. So then we need to tie ground to ground. And in principle, this should draw little enough current that the onboard 3.3 volt regulator should be able to deal with it. There's like a smudge of something on there. Oh, it looks like blue tack. Allow 8 of these devices to be... Yeah, I know. What, isn't that freaking cool? There we go. Focus, you fuck. 8 times 16 IO pins. Yeah. Absolutely nuts. It'd be crazy. Because in principle, you could have like these mini boards controlling like a shit ton of inputs. Because the RP2040 chip is powerful enough to deal with that. It's wild. I love the fact that we can get so much IO expansion, and then you can use the other pins for comms. And actually, PC board repair, the RP2040 has 2 hardware I2C peripherals. So you can connect 16 of these. So that would be 16 times 16 to 1 chip. 16 times 16 equals 256 IO. Isn't that crazy? And it has 2 SPI buses. Let me check. Let me check. Hang on. You could add a switcher. You could use a I2C expander as well. RP2040 specs. Yeah, it has two SPIs, so you can get the SPI version of the chip and get another 256. You get 512 IO without doing any trickery. Isn't that freaking wild? And of course you can bit bang the other ones. That is nuts. Actually, yeah, it's got 8 PIO state machines, so you could also run I2C off that too. So does the RP2040, because it's an M0 plus. what is it? Not data sheet. Not data sheet. Reference manual. Oh, not manuals, but get out of here. Let's see here, peripherals. Here, let's see. There should be a map. Anyways, I'm lost. How's it going, Curtis? Timing of I/O is off a bit. Yeah. Gordie Howe Bridge has had 7,500 trips across. Nice. Nothing works as good as dedicated I/O pin. Yeah, for sure. How's it going, Franco? Franco and Curtis. So we're just talking about how the MCP I/O expander, okay, this guy, it has 3 address pins, which means you can hook up 8 of them to an RP2040. And then I said, well, the RP2040 has 2 I2Cs. So actually you can get 16. So 16 times 16, you get 256 I/O off an RP2040 chip. But then I also remembered it's got 2 times SPI buses, and this chip is available from SPI as well. So in principle, you can get 512 I/O using an RP2040 and the MCP chip. Well, MCP chips, you're still going to need 32 MCP chips. Yeah, exactly. MCP 23S17. It's in the same data sheet, actually, right here. 23S17. So you've got a little bit more. These non-connected pins become your things. Should I do a 512 I/O board? That would be wild. I don't know if the RP2040 has enough RAM to handle all of that. I do have an STM32H7 chip coming, and that thing has enough RAM. MC34017. What is the MC34017? Also, we're going to flash the are going to flash the chip. It has booted. Come on, get out of there. Arduino. Open the Arduino. Not now. Go away. Go away. Go away. File new. I really would love to rebuild the Arduino IDE into something more useful. All right. Oops. Let's see if this compiles. Let's see if Quen has screwed us. Verify. Maybe you should print a t-shirt for your first day on the job. Got bored. Wow. Wow. I was thinking of some merch. I was thinking of some merch of like for the channel, like the coffee stir. But I don't know. You guys are the dedicated few. So I kind of don't want to profiteer off you guys. Done uploading. Should be good. You know what I mean? I appreciate you folks being here. I like that you guys are here. And I don't really want your money. Well, I mean, I do want your money, but only if you have a lot and it's extra. So, problem with the RP is there's no, or the RP2040 0. Oh shit, my microphone is flipped. Is there's no power on indicator. Yeah, no. We do a little trolling in here, PCB repair. Don't you worry your pretty little face. We're good. I understood. So this should be cycling the outputs now. So with respect to ground, we should be cycling. Ice cream van right outside your door again. I was just here yesterday. Got a huge cone for £3, but I just woke up, so you just want your cuppa. Yeah, gotcha. I need a good ground reference. So let's do this. Is it going to work? Oh, wait, I should have made a poll. While I do this, start a poll. Will the MCP 23017 work perfectly? Yes. Duh. No. Never. All right, there's the poll. Vote in the poll. Wow, coffee can is a good crown. All your extra money has been placed in the me fund. Yeah, do that. See, that's what I want. I appreciate my supporters. I love my supporters. But I would love to live in a world where I don't need anybody's support. So that's the goal we're working towards. Be a strong, independent woman who doesn't need no man. All right. So I'll let the votes come in a little bit. 67%, 7% is... Oh, 50% says yes. Next vote, and I'll end the poll. So you folks that are here need to vote. Next vote ends the poll. And then we get the answer. Next vote, or like when I get bored, which is bound to happen soon. So we're gonna check it. First, let's check, see if we have power. It might be a good start. How would I go about that? Oh, here. Yeah, 3.3 volts. Successfully on the MCP. Hopefully I didn't mount the MCP backwards. The pin 1 position is right here. Come on. There we go. Zooming in. Whereas the British say zooming in. All right, I'm going to end the poll. Alrighty then. No more bets. No more bets. Okay, here we go. I didn't think of how bad this would be. Let's grab one of these. How's it going, ITT? Welcome, welcome. Welcome, welcome. All right, so it should cycle through all of the inputs. So we're waiting for this to go high. It should be a half second per. So if it doesn't happen, uh-oh. Pin 1 to 8. Uh-oh. Let's go check the logic. Is there a min-max? Yeah. Hit min-max there. So we're going to be told if it goes up. All right, let's check the logic here. So we include the library. Trigger pin 0. Serial begin. Oh, we can also put the tools. Serial monitor. Select a port. Oh. Oh, we might need a pull-up resistor. That is true. All right, let's put some pull-up resistors, because it's true this is my own board, my own implementation. So we may not have the pull-up resistors required. So we need 4.7 k ohm resistors. So I squared C is open drain. So you cannot, the bus cannot be pulled up. The only thing it can do is pull down. So that's why you need pull-up resistors. But usually, if you're used to using modules instead, then you're not going to use pull-up resistors because the modules have the pull-up resistors integrated. This is my own module. So that makes a lot of sense. So let's pull up. We'll pull it up to 3.3. So we'll move this back. 12 and 13, yep. So that's one thing going from the Arduino world to building your own shit, is that in the Arduino world, all of the modules, all the pre-made modules you buy, they all have pull-up resistors for the I2C ones, at least. And you do not get that on stuff you made yourself. You could argue, possibly, that these modules should have pull-up resistors built in, like these chips should have pull-up resistors built in, but the deal is that a lot of circuits don't need it. Or it could be on a bus with other pull-up resistors, etc., etc. It'd be super cool to have switchable ones, though. All right, so let's get out of min-max. Let's hit the reset. And don't know yet. Here, let's hit the min-max. Let's go check the... Let's go check what the serial says. Error again. Check your wiring, SDA, SCL, and I2C pull-up resistors. Okay. Wire library on the RP2040 uses GP4 as SDA and GP5 as SCL. GP4, I often misread 0, 1, 2, 3, 4, and 5. Okay, so 4 is SDA, and that goes to pin 13. Yep. CL goes to pin 12. Yes. Okay. Bidirectional I/O can be enabled for interrupt on change or internal weak pull-ups. No, you need pull-ups for the I2C bus. Oh shit, we didn't. Yeah, we did tie these to ground. A0, A1, A2 to ground. Okay, can you explicitly set the I2C pins on the RP2040 to not convinced the same defaults always apply. We aren't importing wire.h either. All right. Updated bulletproof sketch, it says. This is crazy. Quen is so slow to respond, but look how fast it writes code. Wire begin, wire and yup. All right, let's try this. Control A, Control V. We're gonna verify it while I reboot the Pi. I'm just going to hold down reset, no, boot. There we go. I'm getting all sorts of new maxes, but it's 0.626. Okay, and then we're going to upload. You definitely need pull-up resistors on I2C lines if you aren't using prefabbed modules. And there's no way the RP2040 has them built in. And the simple reason behind that is that you can set it to any pin. All right, reset. Let's see if it still not initializing MCP. Something is wrong. So we might have fried the MCP. This is another possibility. So the intelligent thing to do is to scope the I2C lines. Or just commence the crying. So whichever one is most convenient. So let's, because I actually have a scope that fits on the bench now. Let's scope the I2C, shall we? Where are my scope leads? I mean, this room is absolutely filled to the brim with scope leads. Scope leads, you make my day. Hey. Oh, I had one job. Okie dokie. Let's turn this on. Okay, so 10x on the probe, 10x on the probe. That's good. We want to ground the test leads. They should share a ground, but I will ground both. Because why not? So there's one, there's two. All right. And my SDA will be my yellow. Right? Wrong. Be my orange, my yellow, and SCL. There we go. All right, now we want to do turn on channel 2. Something's going on. What's the volts per division? I don't even see it. Oh, there. All right, let's reset. Okay, I'm going to set the trigger a little bit higher than that. Oh. I'm not getting the trigger. So, is nothing happening? Oh, wait. 10x. 10x, good. Can you just say run? Run? We're not getting anything. Nothing's happening on I2C lines. Okay, wait. Something's up because we should have... We have no voltage on... Oh, it's AC coupled. Idiot. DC coupled. DC coupled. Okay. So we need this 1 volt per division. Need this 1 volt per division. Okay, and then we need our trigger to be negative. Yeah, down here, sure. And we go single shot. I mean, I think we caught the reset. Oh. No, we have some stuff going on. What is going on? Does the IC generate its own clock, or is it external? Good question. I would assume it has its own clock. No success yet. So it has nowhere to accept a clock. Oh, does the reset need to be tied high or low? That's a good question, because we did nothing with the reset pin. So 18 is not reset. So not reset to me means it needs to go to ground. 18. Did it connect now? 9:16. Oh, it didn't do anything on the serial monitor. Just check again. Reset. Still error, could not initialize. But we do have 3.3 on the bus. Okay, so let's tie not reset high then. If that's how you want to play this game. That's ground. All right, let's reset. There we go. There we go. Okay, so not reset needs to be tied high, which is weird. Not reset. So reset high. If you want not reset, it's high. Okay. Okay, needs to be tied high. And here is the I2C data coming through. So I'm thinking that's the clock pulses. Oh. So there's our clock pulse in blue. And there's our data. Can I? Oh yeah, I have to move it like this. So yeah, there's our I2C. It's like really bad at triggering. Let's trigger on channel 1. Trigger channel, oh, it's channel 2. Is that better? Nope. Not better. But anyways, you need that scope, huh? So this is the Finersi 2D15P. I would, if you have a YouTube channel, I would just reach out to Finersi. They probably will send you one. I don't recommend it, but I can see why you would like it. So I don't think it's worth the price, is what my problem is. So there's the 3.3. So that one's confirmed. Go on to the next one. Oh, I wasn't even on the first one. Okay, first input. Works. Second input. Works. Third input. Works. Output. Fourth output. Works. Fifth. Works. Sixth. Works. Seventh. Works. Eighth. Works. Ninth. I think I saw it there. Works. 10th. Oh. Works. 11th. Works. 12th. Works. 13th. Works. 14. Works. 15. Works. 16. Works. Okay, all 16 outputs function. Now, we link pin 0 to ground. Let me see if I can find another jumper wire here. So if we link pin 0 to ground, there's pin 0, link it to ground. Okay, now we can read the GPIO. And can I make this text bigger? No, can't. But you can see all the ones here. So they're all reading high. And now I can just short to ground all of them one at a time. So we should have one low. Yeah, one low. You can't see it, but you can see right here. Right there, that's low. So I'm gonna go across and make sure we got one low. Yep. Yeah. 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 Yep. Yep. And this row is the harder row for me to do. Where is it? Yep. 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 So everything works. You have a scope that's too small. Had 3 scopes 2 years ago. What happened to your scopes? So we are good. Look, the battery's almost dead already. It's in the red. There are better tabletop scopes. Yeah, I don't have any I can recommend to you, for the simple reason that this is the best tabletop scope I have. Now, benchtop scopes, different story. Got a lot of those. But for video making, the way my camera is set up, this is very nice. I would rather have like a tablet type scope, but it's not, it doesn't really work that well in my setup. I think at this point I just want a scope, like a regular ass benchtop scope with the HDMI out. And I don't think any of my scopes have HDMI out. Let's see. The Unity. So the Rygold definitely doesn't. The Unity does not. And the Siglent, oh my god, the Siglent's so heavy, does not. So yeah, I think at this point I would just like a nice benchtop scope with HDMI out for my video making. Oh no, oh that's bad. I'm sorry to hear that, PC board repair. I could recommend a good Finercy one. Older one Dan has, but it's not made anymore. Doesn't have a model number. Rigol has a computer utility that will connect through USB. So both the Unity and the Siglent and the Rigol, well, so all three of them, they have that USB functionality. My poor suffering computer has so much shit plugged into USB at the moment that I am really not looking to add any more USB. I would like to just do straight video capture. I want an HDMI switcher, which I have HDMI switchers, and be able to video capture. So yeah, not a fan. Okay, so this is good notes here. I have to write some notes. And I have to write notes because the whole goal of this project is to sort of do engineering notes. So MCP 23017 notes. All right. Powered with the, so okay, let's tested. Okay, let's start from the beginning. Soldered onto a SSOP to dip adapter. Tested with an RP 2040 0 was at hand. ESP32 will be the same. Had Quinn generate some code to explicitly set the I2C addresses, I2C pins, cycle through Rigel has exactly. Yeah, but I don't want to. How much would it be? Rigel scopes. Products, digital scopes. Probably want about 250 megahertz. That's not too bad. 12-bit. Does it have? It does have HDMI. That is cool. Oh my god, it's tiny. Wait, does it just fit on my desk? Is it powered by USB-C? Is this my dream? DHO 924S. DHO. Okay, wait. This is American dollars though. That's gonna be expensive. 924. What's the S? What's the S difference? What's the S? Overview. What's the S? What's the S? What's the difference? I kind of like this. Okay, let's search for the S. Let's see if they have it here. That's a bit murderous. Ouch. That hurts. Here's my question though. When you plug in the HDMI, does it turn off the screen? Because if so, I freaking hate that. There's like soldering microscopes that do that. That they'll do HDMI or screen. And it upsets me. That's not bad. $1,200. I kind of like it. Got to run. Nice video. See you later. I got to get ready for your live soon. Very nice. What time's your live? Because if it's at like 11-ish, I'll just shoot people to your stream. You don't schedule. Okay. I just mean today. When's your live? I want to send people to your stream once my stream is done. Let's check. TUS. Okay. Fair enough. I mean, I just wanted to plan. Instruments. Oh no. This site is broken because the banners. Oscilloscopes. 8-bit or HD. So UPO. No HDMI. VGA though. I don't really want VGA. $1,500. Yeah, okay. The same chassis will have the same specs. So UPO, this is what I have already. Might have to go way too expensive to get my HDMI out. What is this? HDMI. Okay. Beauty though. I think I like the form factor of the Rigol a bit more. Wow, USB 3 and a bunch of USBs. Whatever. I'm not buying a scope right now. I've got so many scopes. Cycle through the outputs, test them. When GP0 cycle goes low, is pulled low, default high. Low, default high. MCP IO comes digital read, digital inputs, and displays status on serial. Was able to confirm all 16 channels functioning as input with pull up and outputs. You continue the soldering now. What are you soldering? I'm interested. MCP 23017 connections. Give me this. Pin 1 to 8 and 21 to 28. Pin 1 to 8, 21 to 28, GPIO, where's my whiteboard? 18 pin 18 not set 3.3 volts. Pin 15 to 17, A0 to A2, I had to sneeze. You burned yourself the other day. That's bad. GND to set address to default. Pin 14 NC. Pin 13 SDA. Pin GP4 RP 2040. Pin 12 SCK. Pin GP5. RP 2040. Pin 11 NC. VSS. Oops. Pin 10 VSS. 3.3 volt. RP 2040's regulator. Oh, no, no, pin 9 VDD, and then pin 10 VSS ground. There we go. Then RP 2040 0 wave share. So just writing these notes so that I can put them in my build log. GP4 SDA to pin 13 MCP, and GP5 SCL, pin 12 MCP, and then GP0 floating high from internal pull up, and switched to low when wanting to switch states. There we go. So this is stuff I'm going to enter into the burn log. I just read your comment again, Franco. Into the build log onto my GitHub. So that's good. All right. So I think it's time for another coffee. And then the next thing we do is we're going to test the 2K ohm resistors. Where'd they go? Where'd you go? I missed you so. Oh, here. 2K ohm resistors. We're going to get our, we're going to test it in this situation. And then we're going to essentially, the next thing we'll do after that is we're going to link it to the MCP, and we'll just make sure that our input stages are working properly. All right, so I'm gonna be right back and get some coffee. If I can find my be right back coffee. Where's my sign? I don't know where my coffee sign went, but thankfully getting coffee. There we go. All right, be right back. And I'm back. Guess who's Bizak? Back on the block. There we go. Alrighty then. So I think I'm good. I can erase this now. Just curious. Thank you. Thank you, Franco. What happens if I put a couple drops of rubbing alcohol? Oh god, that made it worse. That made it much worse. Okay. But I think alcohol will make it better if you use something clean. Right? Like, oh, that was a little bit of too much of a squirt. It might be a bad idea to have access to this much alcohol. I mean, I think every once in a while I can clean the board up with some alcohol. All right, so next step is to replace this 1K resistor with a 2K ohm resistor. Make sure it's fully dry, it might ruin the pen. Yeah, I'm not going to write on it until it's dry. Oh yeah. All right, so 2K ohm resistor. So this is 1 watt, 1%, 2K, 50 of them. I do love these 1 watt resistors. Look how big they are. Nice chunky monkeys. Oh, they make a great sound. Don't know if you like that, but I do. Ugh. All right, let's confirm that they are indeed 2K. We've got red is 2, 2, 0, 0, with brown is 1, so 1, 0, and brown is a, is that 1%? Yeah, it'd be because of 1, so 1%. That makes sense. Actually, let's just confirm as well, because you never know. Although I don't know what the utility would be to have counterfeit resistors, because they cost so little. So 2K. $2K. 2.007K. So 1% would mean, you know, ignoring the counts, the accuracy of the multimeter and the counts. 2K, 1% would be 2.02. So this is good. Okay, so like so. The leads are much longer, and actually on the, they're supposed to both be 1 watt resistors, but the leads are much thinner on this one than they are on this one. It's interesting. Also, while I was making coffee, I peeked outside. I do not have a delivery yet. So probably not going to be able to build the watch before I work, which is sad. I was hoping for it. In fact, I'm going to just check. Just going to check real quick. Let's see. If I go on my AliExpress, you guys won't be able to see this because I don't want to give you my shipping address. Although you can have my PO box address all you want. It's on my website. It's on my channel. Track status. This tracking number for this courier. In transit. Okay, when are you delivering it though? Sent to local warehouse for delivery at 3:20 this morning. So it could be coming. Oh, this is interesting. I love these spam emails. So, hang on a sec. See if I can put the do not disturb mode. It's a little sketchy. Whatever. So you get an email with a GIF. Oh my God! Still waiting for the movement. Yes. Yeah. So you get an email with a GIF in it of you going through your channel, and they try to say that they can work on your channel to get you way more followers and all this stuff, but the GIF is just like a link that you click. Full spam. But yeah, still waiting for the movement. The bowel movement. Okay, so let's bring up the diagram, but what I'm pretty sure this is our output. So this leg here is our output, and this is our positive input here through the diode, through the resistor, and then to ground here. So this is our input ground. So input positive, input ground. And then here, this is our output to the MCP whatever. So we need to test this stage as well. I'll pull up the diagram just to make sure, which is on my GitHub. Okay, screen, open robotics platform, architecture. So yes, indeed. And then we need to power by a 3v3. We need 3.3 volt logic.
And so we need to check at the end of the 470 ohm resistor whether or not we're going to have the MCP's required input. Oh look, here's the reset, which I should have needed. So let's find out. Decode. Sure, rise rate. Supply current, 1 milliamp, that's fine. Standby current, 1 microamp, that's crazy. Input low, input high. So 0.25 VDD plus 0.8. So we are looking for how's it going, Jackie? You like analog scopes? They're way too bulky. I have one here. I have a Hitachi V212. Yep, V212, 20 megahertz. It's on my workbench, but it's like up top where the devices are. This guy was my first oscilloscope. Didn't use it very much because it's actually funny symbols. Yes, it is. Yep. The problem with analog scopes, first of all, they're not digital storage, so you need to catch the waveform as it goes. You can't do like a single shot. It doesn't work like that. The other thing is your vertical lines are nearly unreadable because your CRT beam scans from one side to another. So I have this. I'm probably going to give it away to some makerspace or something. Let's see. So I need about 1.65 volts on the output. No, correct, they don't have refresh rates. They sort of do. They sort of do. It's it would be the speed of your scan, right? So we're looking for 1.65 volts. I think I'm actually going to put my board down here. I think I'm done with this. I think I'm done with this stuff. So I can erase all this because I got that written down. We're just going to take our notes here. Okay, let's grab this. All right, so we need 3.3 volts to here. Wait, how do we do this? Oh yeah, 3.3 volts and ground here. And then we need to measure from here to ground. So that's what we need to do. Okay, so let's set up the multimeter to measure. Probably we'll use some custom leads. Yeah, me too. Digital scopes are so much better.
I understand the CRT aesthetic is pretty nice, but like in terms of usability, like I think the last professionals who are using analog scopes are graybeards who refuse to change their ways, essentially. Which is fine. You know, stubbornness is, it's a thing. It's a thing. All right, so we're gonna just plug into this. These are very low stakes measurements, so we don't need to be too concerned about it. So here is our signal. Here is our ground for the scope. Scope for the DMM. Okay, that's good. Now we need to provide 3.3 volts. We'll probably do this via the power supply. Probably do both channels. Let's see. Should have a... Nope. Should have a banana to crock clip. I do indeed. Digital scope. Your old Philips scope can be run on batteries, allowing for floating ground. Yeah, the Finersi we've been testing for the last few days does that too. Okay, second channel. In fact, I was just learning today that there's a market of scopes that have USB-C input now instead of mains input, which means that you can power it off a power bank for essentially days. Like, you're just limited by the size of your power bank in that case, so you would also have isolated power, which is great. Okay, so that's good. Now the other channel has to be powered by the power supply as well, and that's the one we're going to vary. And again, we have banana plugs. I'm really interested in the next generation of scopes with all the bells and whistles, the outputs to HDMI, USB-C power. Let's see. It's ground. Okay, and this guy can just hook up to here. Now, I do need to make sure that my my thermal camera is ready. I mean, if I need to, I'll just do other thermal camera measurements. But let's just vet everything. So channel 2 on. So right now with everything off, we've got no output, which is good. So we got 3.3 volts here. Now I can turn on channel 1, set voltage. Let's go 3. Enter 3 volts. Just switch that one on. So there we go. So we should have 3 volts, and already I'm seeing an issue. At 3 volts, we're not getting a logic high here. That's not good.
Let's creep the voltage up.
Here's 5 volts, 6. All right, now I'm thinking something is wrong. Because we are not...
something is wrong.
Okay, we still need to power the positive side here. Okay, that's good to know. Six hours of battery. That's pretty good. Okay, so we're powering the positive side here.
Okay, so we have 3.3 volts here. That's on. Where's my thermal camera? Man, my thermal camera is like this huge thing that you could use to club someone to death if you wanted to. You'd think I'd be able to find it. It also doesn't go very far. I use it like at the same spot all the time. I use it here at the workbench. And if you think I'm joking about the fact that you could club someone to death with it, I am not. Okay, here we go. Found it. So, only thing I will say about this thing that I don't like, it kills the battery when it's plugged in. Calibrate your scopes to a rubidium frequency standard. Can't imagine trying to do that on a digital scope. Digital scopes hold their calibration for far longer. Like, you should check the published ppm and drift numbers for digital scopes. Modern digital scopes. Of course, if you work in a critical environment, you definitely need to calibrate it, but I'm just saying a lot less often. Okay, so here goes. So I'm powering it on. So it's on at 1 volt, and we do not have it high. We are looking for 1.65 volts. 65 volt threshold. Okay, so it's 1 volt. We were able to get at 1.8. So we're at 1.9 now. Yeah, we're not getting it. 2 volts. 2.1. That's just barely 2.22. There we go. 1 point. So 2.21 volts. 211 volts minimum. So on the input here, we need 2.21 volts minimum before it will conduct. And before, when we used the 1K ohm, we were getting it at 1.88 volts. So this is a major concession, definitely. Uh, 2 volt minimum is a more than respectable figure, is what I wrote, and we'd be sacrificing a little bit to go 2K. 2K resistor. All right, so 2 volts. So let's check the dissipation. Oh wow, I was like, what's so hot? It's my coffee cup. All right, so here
There's really nothing to it. What is that? Is that the... Oh, it's the test lead. Oh no, is the SD card not in here? Oh, you idiot. Now, where's the SD card? Okay, here. Gotta put the SD card back in. There we go. Now, can I take a screenshot? Yes, good. All right, that's done. Amps and caps mostly, just calibrate. Yeah, I mean, makes sense. All right, 5 volts on input. Oh yeah, sorry, and I get at 2.211 volts, 0 milliamp, and 0 milliwatt. All right, and we go up to the next 5 volts on the input. So let's bring this back down to 0, and we're going to go 5 volts, 5 volts. All right, so on 5 volts, we get 0.01 and 0.05 watts. We're going to let that heat for a little bit. I don't think the resistor is going to get hot, but we're going to give it a couple minutes to stabilize, because right now it's at like nothing. The heat you see right there, that's actually the lights reflecting off of the claws of the crock clips. I'm going to give it a few minutes to heat up. I don't think at 5 milliwatts it's going to heat up. No, I think it's pretty safe. Pretty safe to say it's not going to heat up. Trying to catch it so it doesn't reflect as much. All right, next stop, we're going to go up to 12 volts. This one might heat up a little bit. So that's 12 volts on the input here. So at 12 volts, we are getting we're getting 5 milliamps. Oh, we're missing a 1 here. It's 0.00. It's 1 milliamp. 0.005, so 5 milliamps. And 0.06 watts. So 60 milliwatts. It's very little. No, I agree. I agree, Franco. I'm just capturing everything for data's sake, because it's going in the build log on GitHub. So now we are getting a 32-degree skin temperature for the 2K ohm. So I'm going to let that, so 32.7. We're going to give that a couple, like another 30 seconds, see if it goes up. So we were getting 42 before, so that is a much cooler temperature. Still heating up, 33.4. Give it another 30 seconds, see if it's going up. Gotta love a thermal camera. $34.2. Seems to be at thermal equilibrium now. $33, $34, calling it something like 34C. All right, so we have improved quite a bit over the 1K. 24 volts is next. 24 volts. So now at 24 volt, we are at 10 milliamps. And we are at a quarter watt, 0.24 watts. And that resistor is going to get hot. It was at 106.2 before. It's at 54 and climbing. We're aiming for an input of what are we aiming for? 45C. So 2K ohm is not going to be an acceptable resistor. We may have to do a MOSFET input stage. 61 and climbing. Starting to definitely get warm there. Thing is, you don't want a newbie touching one of these. Like for me, it doesn't matter. I have touched far hotter things. $60°C. But like, you can't allow kids to work with this. So we might have to go with a MOSFET input stage with like a pull down. Maybe like a weak pull down. So I think quarter watt is fine, but like 63C, we used to be at over 100 here. We used to be at 105. see if it's still climbing. 63. I think we're pretty much plateaued. 64. Yeah, I think we're plateaued. I'm gonna give it another 30 seconds. Kids should work with stuff like that, get hot blow up. I mean, that's your opinion. When you have 20 little shits in your care and control, it takes one parent to complain to the school board, and then nobody learns about robotics anymore. When I suggested to one of my friends who teaches at high school some easy soldering stuff to do, they said they couldn't do any soldering because of a parent had complained about fumes and heat. And I agree that some kids have aptitude and they should be allowed to experiment like this. But the thing is that not every kid has aptitude. And so when you have to deal with a large group of children, it's not a good combo. All right, so we got 63.7. .7C. So way better. Definitely way better, but I think we need to look at a MOSFET input stage. Because yeah, not good enough. So yes, I agree. As much as I'd like, as much as my philosophy is with proper guidance, anybody can do anything. The problem is that it's hard to get proper guidance, and one person complains and the whole system falls apart. Taking a butter knife to a Super 77. Well, and I mean, I think kids should be allowed to explore like that. I agree with you. But it can't be in public settings because there's too much liability and everyone is so litigious. So let's check like a standard Super 77. I think it's a reel-to-reel. Am I mistaken? Oh, it's a TV. Okay. Wow, really can't find it, huh? It's a boombox. This guy?
All right, so let's look at a 2N7000 MOSFET. Canada, obviously. Okay, so drain to source voltage 60 volts. That's good. $20. That's not enough. Okay. Let's go on to so the problem with adding a MOSFET, I don't know in the country where I am, you learn to solder electric young. What age? Don't forget, North America has become a big group of babies. Our education system is a joke. Every time a parent complains about anything, the whole system shuts down. I hate it. I really, really hate it. Okay, semiconductors, discretes. So we want MOSFETs. SMD. Applied filters. Maybe we're going to get new filters. So in channel. Oh, we can get up to 8 channels. That's interesting. 1 channel. Uh, 4 volts is as small as it goes. Oh, threshold. I mean, lower than 2 volts. Smaller or equal to. Oh. All right. What's not allowing me? Results remaining 0. Okay, let's just reset this one. What did I do? Less than, okay, less than 3 volts. Zero. That doesn't make any sense. Okay, so we want at least, let's go 30 volts and higher. Okay. And then the rest is gray. Okay. I'm confused. So 4 volts. Oh, threshold. No. I'm confused. Whatever. Let's check the cheapest shit we can get. 2N7002. Let's see what we got. $12 to $13 is fine. Yeah, I mean, we can't do that. It's the American culture of suing everyone. We don't have that in Canada as much. See, you need like 4.5 volts. What's the threshold voltage? 1 to 2.5 volts. Yes, I agree. The kids should learn to listen. That's not the reality. You realize that we don't fail our kids anymore. Here, we'll use ChatGPT, sure. Is it true that for the most part in elementary and high schools in North America, kids don't really have to repeat grades anymore if they turn in unsatisfactory work? Yes, that's true. Canada and the US have shifted away from making students repeat grades. Grade retention today is relatively uncommon for students to be held back. This is part of the parents complaining, by the way. Summer school, yeah, but they still push you through modified assignments. That is a pain in the ass. Modified assignments, just do something simpler. Social promotion, that's pretty bad. Is it true that students entering university in North America today tend to be functionally illiterate at a rate never seen before? No. There's real concern about academic preparedness of many incoming university students, but the claim that they're becoming functionally illiterate at a rate never seen before is not supported by evidence. Interesting. Many professors report a decline in reading and writing skills, increase in faculty complaints about students struggling. Okay, this is what I meant. So students are struggling to read long, complex texts, write coherent essays, synthesize multiple sources, and follow detailed instructions. Hey, screw off. These reports have become especially common since COVID. Standard assessments show declines. Yep. Reading scores for elementary and secondary students in both US and Canada have generally declined over the past decade, with sharp drops after 2020. And those weaker cohorts are now beginning to enter university. Yep. However, universities have expanded access. That's interesting. Compared with 40 or 50 years ago, a much larger percentage of the population attends university. That is true. Okay, I didn't think of this aspect. That's pretty interesting. Well, I know in Canada, my niece and nephew, they missed a big chunk of the school year and they just got passed on to the next grade. The first year of the COVID lockdowns. What's more accurate is that some students enter university with weaker vocabulary, less reading stamina, poor grammar, limited experience writing analytical essays, and difficulty distinguishing strong from weak sources. Yep. Social promotion means some students advance without mastering earlier material. Yep. Pandemic learning disruptions cause measurable setbacks. Yep. Smartphone social media may reduce the amount of sustained reading many students do outside of school. Yep. Grade inflation can allow students to earn high grades despite gaps in mastery. Yep. And Gen AI. That's funny because it's Gen AI telling me this. So yes, there is a problem. There's definitely a problem, but it's not as bad as I had thought. Look at that. I know for me in the trades, there was definitely a big problem. Tradespeople tended to be less interested in reading or writing tasks, so they were weaker in general. I had some really strong academic types. Don't get me wrong, but the average was much lower. And since COVID, it definitely got worse. 100%. Like much, much worse. You blame social media? I mean, social media does have an impact. It is named here too. Okay, so that is not great. That is the same thing. $50 volts in channel. You know what? This might be a case where LCSC might be better. So I guess my big issue for the US, it's totally voluntary. What is totally voluntary? So I guess my way easier to control a population when they are stupid. Yes, of course. I do believe that education has been de-incentivized, and I think it's just a fun fact, you know, definitely, like, let's 100%, we'll say that. So, okay, so my problem is YouTube isn't the same as
what's being known as social media. Yeah, YouTube can be what's known as social media too. I mean, you guys are effectively. I mean, you guys are effectively social media users right now. We do have a relationship, which is parasocial. Let's not ignore that. Okay, so this is your PC817 here. Probably should have drawn this a bit different. All right, I'm just trying to do it like on the edge of my screen here. Let's pull this out like so. But yes, like let's not be mistaken. YouTube is social media. But the other thing is, we are adults here. We're not in school anymore. You've just bypassed the diode. So here's a PC817. So this is an LED. Okay, now if we put a MOSFET here and put the input here, we still need a power supply here. Adults are impacted the same. Okay, but that's not what I'm talking about, ITT. I'm talking about when you're in school, when your job is to learn. Right now, our job is not to learn. Like, obviously I love learning, but I think there's a big difference on what happens in your formative years, between what happens in your formative years and what happens when you're not so formative. Big difference. In the US, learn to solder when you were 8, fillet a fish at 7. Yes, yes. And again, with the one-on-one attention of your parent and guardian, that's different. I'm talking about a classroom with 20 kids, and let's be honest, these days, more like 40 kids. All right, so the problem with using a MOSFET input is that you need to supply power for the DS, the drain source side. Social media isn't conducive to higher education. You sit in on MIT lectures on YouTube, and not everyone wants to learn. Of course. I agree. I don't think anybody's disagreeing with that. So if we need to power this so that we don't actually get our proper isolation, unless we use an isolated power supply, and that gets complicated. So my idea for just using a resistor is so we can just power this LED on. And then be done with it. I ignore 99% of social media except TikTok and Instagram. Those are the best news sources. Okay. I haven't done TikTok yet. So how do we deal with this? So we could use the PC817, okay, hang on a sec. So what if we use what if we use the PC817 Jackie, I suggest you come out of your bubble a little bit, because the term fake news is just used to say the news that I don't agree with. You need to vet all of your news sources. Okay, as I was saying, what if we did this instead? What if we used the PC817 to trigger a like 2N3904. So then at the really low threshold here, we will still have like an amplification value on the base here. Or even this can be, you know what? This could be a 2N7000. So what is the threshold for a 2N7000? To N data sheet. We might have a better. So this is all on the 3.3 volt side. VGS threshold 2.1 volts. I think this would work. So I think if we take our, where's my GitHub? If we take our input, I need to go up again on the 1K, sadly, on the 2K. Okay, so if we instead here, let me move this shit out of the way. Okay, follow me on this journey, folks. So you have the input. So you've got so input, and then here you have a diode, which is the 1N4148, 1N4148, which is a signal diode. Then you have a 1 watt, let's say 5K ohm resistor. And then you have that's the PC817, PC817. Okay, and then you just ground to here. Oh, I'm a freaking idiot. I could just use multiple resistors here. Anyways, whatever. Let's continue with what I was doing. So this would be your transistor. So this would be 3.3 volts. Then this would come down to that's a 2N7000. So this would also connect to 3 volts. And then down here we would have our 400 and oh, here we need a 470 resistance. Then down here we get our to ground our resistor and capacitor filter. And then this would be our, this would be 10K and 100 nano. And then this would be a 470 ohm, 70R. So this would just have to go enough. Oh yeah, and this we need to pull down like 100K pull down. So this might actually work. So what time is it? It's 11. Okay, so the stream is done for now. Tomorrow we will come back. We will build this input circuit and see if it works. Now the 5K would be good, but I think I can do 5 1K resistors and then keep the quarter watt resistors there, and that can be replaced by tiny SMD like 0602s or 0402s or something like that for more space on the board. And then this would go to your MCP 23017. So this might be the right thing. We might just use the incredible gain from this. Let's see. We'll see how we can make it work, and we'll go from there. How's that sound? So I think this is what we're going to try. We're going to see if we can get the gain back under control, and then we'll go for it. I have two N7000s in stock, but we can find a very, very low V threshold MOSFET and then order that. But okay, enough for today. It's time to go eat. Thank you so much for being here on the stream, and I'll catch you on the next one. Bye.